Oh, hello. Yeah, so here are the videos for Unit 2, Days 2 and 3. So we're looking at combinations today, and I think my pen's working better, so we're good to go. So this is probably 2 days worth of work, maybe 2.5, somewhere around there. And things are going to change a little bit. Before we were doing questions like this, you had a bunch of people, you want to put them in a line, and everything mattered, order mattered. Now today's question is not that sort of thing. It's where order does not matter. You're choosing, but you're not ordering. Okay, you're not putting them in order. And these are combinations. Okay, so combinations. The other ones are permutations. Remember we had the P. Now gets involved. So P, order matters. C, order does not matter. So example, you got some pizza, and you get 2 toppings. So you get exactly 2 toppings. We can do more than 2 eventually, but let's keep it simple. Just 2 toppings. Bacon, pepperoni, mushroom, ham, and extra cheese. Those are your toppings. I don't know if this qualifies as a topping, quote unquote topping. But anyway, we mess around with that and we figure out how many different types of pizza you get. Now, the key is this. If you go bacon and pepperoni, that's the same as saying pepperoni and bacon. So if you ordered, you call someone up and said, I want a bacon and pepperoni pizza, and I called someone up and I said, I want a pepperoni and bacon pizza, and we ordered from the same place, we get the same pizza, same looking pizza, okay? So order does not matter here. So before, if I said do this and give me 2, it was 5p2, and it was 5 factorial over 5 minus 2, which is 3 factorial. Now, one way to think, and that'll be 20. One way to think about this is this number now, so that would have been if order matter, order doesn't matter. So the number of pizzas is going to be less than 20. Okay, now let's try to figure out how much less it is. Well, I'll tell you, if we messed around with this, which we will in class, you're going to find out that there are 10 pizzas. Okay, and that's a different question, like I said, than this here. So if I said, what are your 2 favorite pizzas, that would be the lining up P52, or favorite toppings. Sorry, if I said, what are your 2 favorite toppings, you would say bacon's my favorite, and pepperoni is my second favorite, and blah, blah, blah. And then you could come back and go, no, pepperoni is my favorite, bacon's my second favorite, blah, blah, blah. These are order matters. This is not order matters. So what's going to happen is this number will get smaller. Now, how much smaller? It looks like half as big. And the reason it's half as big, I'll give away kind of the punchline here, is that you're going to divide by the number of things you're choosing, factorial. So this here, let me just do this here, NCR, which we call NCHOOSR, which you might see in some textbooks, not ours, but you might see in some textbooks as this, like a long bracket with an N and an R in it, is equal to N over N minus R factorial. So that's what that, so remember this, right? That was equal to, N over N minus R factorial. But we also divide by one more thing, and that is the R. So R itself gets in there. So what we're doing here is we're getting rid of all the unique ways that we don't want anymore. So before, when we did this, we said that B and P or B are different, but in our case now they are not. So we're going to divide by a little bit more. And that's not R, sorry, that's R factorial. Okay. So let's do this one example. What's this? If I want to, there were 7 pizza toppings, and I can choose 3 of them. Okay, throw them all over the pizza. So that's 7 factorial over 7 minus 3, 4, and then 3 itself. Okay, so this is that, and this subtract that goes there. That's it. What's the answer? You go ahead and figure that out on your calculator. Okay, so let's look at this. How many ways can I choose 3 students from this class? So let's pretend there's 30 kids in the class. That's this question. Okay, also this. Okay, and that is, 30 choose 3. That's this. Don't forget, you have to add this. The only difference between the questions from before and the questions now are we need to get rid of all the unique ways that things are ordered. Okay, we're going to get rid of all, knock them out. And if you go, well, why is it 3 here? Well, think about this. If I chose students A, B, and C, right, how many ways could I have chosen them in order, right? So if I had to choose 3 students to be president, vice president, and treasurer, that's, P, V, and T, right? I would go, okay, well, I have 3 different students here, and I chose them, okay? So I would have ABC, I could have ACB, and I could go through it, right? So I'd have 3 factorial ways to line these kids up, right? Because there's 3 different things. That's 6 things, right? But I want to get rid of that uniqueness now. ABC is the same as ACB because I'm just choosing them. So if I said, hey, ABC, come on up here, or if I said, hey, ACB, come on up here, it's the same thing because they're doing the same thing. Okay, so that's that. You work your way through it. Can we reduce like we used to? You can. Okay, so this will reduce. This will cancel out all of the other stuff. But then after that, you are going to have 3 factorial after. Okay, so there's no quick way to reduces. You could look at this and say, okay, that divides into that. That's 14, and that's 10, and you could go 10 times 29 times 14, something like that if you want to, but you don't need to. Okay. This is kind of neat. So shop owner wants to put up 3 of his types of roses on sale, and you find out that this is the way to do that. Okay, and he has 7 types of roses, and he wants to put 3 for sale. How many ways can that happen? 7 divided. So that's this. C 7 3, and that is that. Now, the next question is, what happens if he wants to put 4 for sale? And if you do the math here, if you do this again, actually, hold on, let me just do it the way I would. You go n minus r, which is 7 minus 4, which is 3 factorial, and then 4 factorial. Now, if you look at this, 3 factorial, I have 4 factorial and 3 factorial here. I have 3 factorial and 4 factorial here. Whatever that number is, it's the same. So what's going to happen is these are the same, and if you say, hold on, how can that make any sense? If I'm going to put 3 things on sale out of 7, I'm going to put 4 things on sale out of 7. That's not the same thing. But think of it this way also. When you're doing combinatorials or combinations, that's the C questions, not the P questions, you are basically dividing things into groups, right? So if I go ahead and I say, let's put these guys on sale. Let's go pink, red, and green. I don't even know if there's a green rose, right? And then let's not put these on sale. I don't know, orange, blue, brown rose, which sounds like it's not too healthy, and even better, black rose. Okay, so if those are our roses, what we're doing is we're choosing 3 of the 7 in this group, but essentially you're also choosing 4 of the 7 not to be in that group. So, you know, if I said to you, how many ways can you put, so here's the same situation. This guy wants to put 3 on sale out of 7. That's the exact same question as saying, I want to put 4 not on sale, right? 4 of them are not on sale. How do you do that? Well, that would be choosing this, and what's that? That's this, and guess what? That's the same as this. So whenever you're putting into groups like this, you are going to realize that there will be 2 answers per question that are the same. Okay. So for example, another one would be if I was going to put 2 on sale. Okay. That would be the same as putting 5 not on sale, right? So it's the same question with the same answer. Okay. And that's what this is all about. Okay. A big part of combinatorials is cards. So I'm going to switch to red here. So cards, remember there are 52 cards. You got to know your cards a bit, right? So how many ways can you just choose from cards? And I'm just going to do it like this. 52, choose 5, and then let you figure out how that reduces. So 52 cards, I'm going to choose 5 of them. If I was just choosing red cards, this is a lot easier than you think. Okay, all you do is say this. How many red cards are there? How many am I choosing? Okay, 26 red cards. I'm choosing 5. I'm done. Okay, that's the number. That's the number of hands of cards that are all red. Now remember, right? If I have a bunch of cards, I can order them in any way. The whole thing about cards, hands of cards are, they don't really matter. If you get cards dealt to you, have 5 in your hand, you can mix them, move them around within your hand. It's still the same hand of cards. So order doesn't matter at all, right? So that's why it's a combination, not a permutation. Permutation, order matters. Combination, it doesn't. Okay. Hearts. How many hearts are there? 13. And I'm choosing 5. That's it. How many of them include the ace of spade? Okay, so let's think about this. First of all, we get the ace of spade. Okay. So how many ways can you choose the ace of spade out of the ace of spades? Once. Okay. So there's one way to get an ace of spade. So and that's the ace of spades. And then after that, what happens? Well, after I do that, I need 4 cards, and I'm choosing that out of the 51. Okay. So the ace of spade is gone, and then what's left over, you're going to multiply that by this right here. Okay. 51 times. So that's the number of ways to choose to make. Those are the number of hands of cards that have the ace of spades. Okay, they are all the cards that have the ace of spades, and then anything else between chosen from the other 51 cards. Okay, so that might be a little confusing. Contains, and this should have been exactly an ace. So I get an ace. Now, how many ways can I choose an ace? Well, there are 4 aces to choose from. So 4, choose 1. So sorry, that's old school. That's 4C1. And I'm going to multiply that by, well, what else am I doing? I have 48 cards, and from there I'm going to choose 4. Now, here's the deal about this, right? So let's just be careful. Exactly 1 ace. Once I choose that ace, the other aces, that ace there, and the 3 aces I didn't choose, so all 4 aces are not part of this anymore. If I threw them back in here, then you have a situation where you're choosing an ace and then another card. You may have another ace, but this is exactly 1 ace. Okay? If this was not 48, if it was 51, or you try to do something like that, that's a different question. Contains no 7s. So this is a lot easier than you think. If I want to choose 5 cards out of a deck of cards, and I don't want to include the 7s, all you do is this. You go, hey, let's get rid of the 7s. There are 52 cards. 4 of them are 7s. 48 cards are not 7s. I'm just choosing from the not 7s. Kind of neat. Okay. If you want to do 3 hearts and 2 clubs, okay, so this one's a little bit different. We haven't done this exactly yet, but I have how many hearts? 13. I'm going to choose 3. How many clubs? 13. I'm going to choose 2. And all you do is multiply these two numbers together. Okay, so I choose my hearts and then my clubs, or vice versa. It doesn't matter how you do this in order. You're going to multiply, and that's how that's done. Okay, as we move on, we did what you're going to do the next day is we're going to connect these guys. We're going to do all this stuff here, and we're going to connect them all. And the key is that order doesn't matter here. For this line here is it from D to E or E to D? Same thing. Okay, and this question here, you find out here that this is 1, 2, 3, 4, 5, 6. Every time you are connecting a dot, there are 6 options for you, right? So you start off with 6, and then you're choosing any 2 of the 6 to connect. Okay, so it's the same thing. So there's F and there's B, I connect them. There's one line. There's F and there's C, I connect them. There's another line. Okay, so that's how you do this type of question. This is really good when it comes to planning and organizing things. So if you're going to try to come up with the different ways that these things can be done, you can kind of sometimes plan it like, make it look like this. Okay, how does this relate to combinations? Just like I said, I'm sorry, just like I said. So this question is that answer, okay? How would this change if there's 10 dots? Same thing, okay? Now you're choosing 2 from 10. What would happen if you did a triangle? I'm going to let you do that, but what's going to end up happening is you're choosing 3 here. So 6, choose 3. Okay, so you're choosing 3 from 6. Okay, so we'll spend a little more time on that in class, but let's look at this before I run out of time here. How much, the same logic can be used to talk about this. If I want to go to Paris, London, Berlin, Athens, Dublin, and Rome, that's 6 cities, and I'm going to 2 of them. If I wanted to go to two of them, it's just this question here, and let's just refresh what that looks like. That's this, okay? And you work that out and you get a number, okay? If I wanted to go to 2 or 3 of these cities, well, this is a rule of sum type question, so we did this in the past. What happens is you do this one, and you do this one, and you add them together. So how do you get 2 cities? We already did that. How many ways do you get 3 cities? It's this. And again, because they're different, you're going to add them, okay? So rule of sum, here's a scenario, find this number, add them together. Okay, but that's a little different. Let's go back now. And I want to make sure here that this is clear. We're choosing the 2 cities. So we're choosing 2 cities here. So we have 6 cities here, and we're going to now order them. So now before, if I said, look, I've chosen Paris and London. Those are the 2 cities I'm going to visit. I haven't said yet if I'm going to Paris first or London first. Okay, so that's going to be a little different. And the way to deal with that is, so now we're not choosing this. This is a permutation question. So now we're going to order, which is a permutation question. So there's 3 ways to do this. We did it this way. If I said we're going to 2 cities in order, you could say I have 6 choices for the first city, then 5 for the second. So I multiply them together to get 30 different ways I can go from city A to city B. Permutations, that was this. Okay, and remember that becomes this. Okay, just the 4. I don't put the 2 there down, and that becomes this. Right, so remember we stopped here, and that becomes 30. So same thing. And now the question we've been doing is, let's choose the cities first. So this is a doable, this is a real type of question. If I'm going to just choose 2 cities, where do you want to go this summer? Paris and London. Okay, how many ways can I choose that? Well, that's going to be 6 factorial over 4 factorial and 2 factorial. So how many different cities can I choose from? That's going to be 6 times 5. I'm going to get rid of this 4 factorial over 2, which is 15. Okay, but now I haven't chosen yet. Am I going to city 1 first or city 2 first? Okay, and then what you're going to have to do here is, since I'm choosing 2 cities, there are 2 factorial ways to line up those 2 cities. Okay, so after you've chosen the cities, 15 different ways, you have 2 factorial ways to do this. So let me redo this whole thing now. That becomes this. 6 this times 2 factorial. Okay, now how does that look? Let's see, expanded. That's this. Okay, 6c2 looks like that, times 2 factorial. These cross out. This is 6. Again, this is just 6 factorial over 4 factorial, and we already said that was 30. Okay, so you can select, then order. So, if I did this, how many ways can I do this? Okay, that becomes something. And then if you want to order them after and say, okay, now I want them ordered, then it becomes, you have to multiply by 3 factorial. Okay, the last thing I want to look at real quick is this right here. And to tell you the truth, I'm just going to hit pause now, and I'm going to add this video as part 2. Okay, so great job. Take care.